This is going to be the first set of notes on our transformations unit. This is going to cover translations, reflections, and line symmetry. So a transformation is an operation which maps an image to a new image. So an image is just a shape, a point, anything. So right here we have a pentagon. So we call the original figure a pre-image. And we name it by calling it pentagon A, B, C, D, E. So remember, whenever we name polygons, we just have to go clockwise or counterclockwise. So I just went clockwise here, starting with A. So the new figure is called an image. It's not a post image, it's just called an image. And the image above, we would have to name it A prime, B prime, C prime, D prime, E prime. So those apostrophes are pronounced prime. So that should give you a quick idea of what a pre-image and an image is. And a transformation which creates a congruent figure is called an isometry. So now that we have a couple things out of the way, basics of transformations, we're going to talk about a specific kind called translation. A good way to think of it is to slide and glide. So a transformation that maps all points of a figure the same direction and same distance. That's what the definition of a translation is. So if I take a look at P, so we're missing a couple of primes here, maybe they just got cut off. If I take a look at from P to P prime, it goes in the same direction and distance as Q does to Q prime. We do that for each of the points. So we have a translation rule. This means we move all vertices A units to the right because we are adding A. So X plus A moves it A units to the right and Y units up because we're doing plus B. So we have a couple examples here that I think will make this a lot more clear. It tells us to graph triangle ABC. So our original points are 2, negative 1. So that's point A. We have negative 4, positive 2. That's point B. And lastly, we have C, 1, 4. So there's a triangle, ABC. Now we're going to shift it. We're going to move all our x coordinates up 3 and our y coordinates down 2. So 2 plus 3 is 5. So I'm moving that up 2, and I'm going to subtract 2 to get negative 3 for A prime. Same thing, I add 3 to the x coordinate, I get negative 1. Subtract 2 to get 0. And finally, 4, 2. Just following the same rule. And whenever I graph this, so the first point is 5, negative 3, not 5, 3. This is going to be A prime. So negative 1, 0 is going to be B prime. And 4, 2 is going to be C prime. So what I have right here are congruent figures. I have the same exact shape. The only difference is that I shifted it. So that's what a translation is. I slide it and glide it. So for this one here, I'm just going to do this quickly. We have parallelogram T, U, V, W. So this is TUVW. And we would just move it down 4, or sorry, to the left 4 and down 5. So That would be t prime. And then once we have this, all of our other sides are still going to be the same size because these are congruent figures. So that's our shape right there. So remember, that's t prime, u prime, v prime, w prime. So to start off on page 2, there's an example that I would like you to do where it's another triangle where we have the pre-image given to us and we need to find the image. So we're asked to write a translation rule that can be used to describe the translation. So if we move up 8, that's going to be y plus 8. If we move to the left 3, that means it's going to be x minus 3. So whenever we subtract, we move to the left. Think of the number line whenever we do this. So if I have 3 and I move to the left 3 units, that would be 3 minus 3, which is 0. So to solve for b, we ask, how did I go from 4 to 0? Well, I took x and I subtracted 4. 4 minus 4 is 0. And how did I go from negative 6 to negative 1? I took y and I added 5. That's how we come up with those. So I'm going to ask you to do C and D. We're not given the points, but we're given graphs and we can find the points that way. Just write a rule just like we did for the previous two. So for this one here, we consider the translation x plus 12, y minus 7. So for this one, it looks like we forgot letter A, but that's all right. I'm going to do B and D, and I want you to do C and E on your own. So since this is the image, this would be the pre-image right here. It's asking us what is the image of 5, 3. So this right here, 5, 3 is the pre-image, so we need to add 12. So it's going to be 5 plus 12, 3 minus 7. So it's going to be 17, negative 4. This one here, letters D and E, is asking us for what is the pre-image of negative 1, 3. So we have to do things a little bit differently here. We're given the actual image in the end. So we need to find out x plus 12 and y minus 7. So we need to ask ourselves, I'm going to do this to the left here, x plus 12 equals negative 1. So when we subtract 12, we get x is equal to negative 13. And we have y minus 7 is equal to 3. We add 7. So we get y is equal to 10. So the pre-image is going to be negative 13, 10. That's how we do letter D. So hopefully that was enough of an example. D is just going to be like E. B is going to be like C. C should be a lot easier than E. Basically, we just need to do the opposite or the inverse operation. So another concept we need to talk about is the concept of reflection. A transformation representing a reflection of a figure over a line. So reflection is something that a lot of students see pretty easily. This right here, this line segment AB, this is acting like a mirror. So the distance apart from all of these points is the same. So I could say that those 2 points are equal, these two are equal, and all the way through and through. It's just a mirror image. So it says that each vertex of the pre-image and the corresponding point on the image, this should be are equidistant. They're the same distance apart. So we're going to sketch some examples of reflections. So we're reflecting it over line M. This is the reflection line. So these are going to go out like that. This is not very well drawn to scale. Should be just like that. And this is going to be U prime. Or sorry, it's going to be T prime. U and U prime are going to be the same point. This meets here at a point S prime. And that's going to be R prime right here. So basically, if line M was a mirror, that would be what the image would be on the other side. So again, we have line M acting as our mirror. So remember, the points are going to be equidistant apart. So L is going to be just as far away from the line on both sides. The same thing with K, so we can kind of guess where K is going to be. K is the same amount of distance away from that line, and also J. So our reflection should look something like that. This one here might be a little bit tricky because first off we have point P. Point P is going to be, P prime, is going to be on the other side. So remember, N and M are on that side. Well, N and M are going to have to go on the same side as P. So we have to go an equidistance away. So whenever we connect the dots, we still have L and O. They're on the line, so they don't move. And our new image is that one in green. So that one might be a little bit tricky to see. But remember, whenever we figure out that the lines have to be the same distance, so ON prime and ON are congruent segments. That should help you see this a little bit better. So we're going to be asked to reflect things over the x-axis, the y-axis, and the line y equals x. So let's do that for each of these. We're given the points 3, 1, that's point A, -4, -2, that's point B, sorry, that's -3, and 0, 5, point C. And we're asked to reflect it over the x-axis. So right here is the x-axis. So again, we're going to do that same thing. We're going to take point A. It's going to be 1 unit away from the line. So it's going to be 1 unit down. So let me change colors. We'll make it blue. So that's going to be A prime. B prime is going to move up to, and C, it's 5 away from the x-axis, so it's going to be 5 below. So it says it's a triangle, so this is what the triangle is going to look like. The red is my pre-image and the blue is my image. So what did I do there? I changed the coordinates. Did my x-coordinates change? No. So whatever x was before, it's still going to be x. Y did change, though. It became -y. So that's a little shortcut whenever you do that. So whenever we apply that, we're going to have A prime is equal to 3 positive 1, because negative 1 is going to be positive. B prime is going to be equal to -4 positive 2. And C is going to be equal to 0, -5. That's what happens whenever I apply the rule. So we have the graph and we see how it compares to the rule. So for the second one, we're going to reflect it over the y-axis. So again, I'm going to use my pre-image in red. So that's C. A, and B is down here. So this time I'm going to reflect it over the y-axis. So let's take a look at A. I was 3 away, I was 3 to the right, so I'm going to be 3 to the left for A prime. C is actually on the y-axis, so I don't need to move it at all. C and C prime are going to be the same point. B prime, though, 3 away, 3 to the left, so that's where it'll be. And remember, C and C prime are the same exact point. So there's my image in blue, and my pre-image is going to be in red. So let's think about what happened there. This time our x coordinates did not change. Remember, x coordinates did change. They became negative x. So for example, our pre-image, A was 3, 1. Now it became negative 3, and we didn't change the y. The y stayed the same. B prime, the same thing. Our x coordinate became negative negative 4, which is 4, and our y coordinate didn't change. And finally, C didn't change at all because x was 0. Negative 1 times 0 is still 0. The last one we have is y equals x. So again, we're going to plot our pre-image. So 3, negative 1 was A. Negative 4, negative 2 was B. And 0, 5 was C. So that's our pre-image. So we need to think about what the line y equals x looks like. It has a slope of 1 over 1. So there it is right there. So in order to come up with the image, we need to have a line that's perpendicular. So that's how we find out the distance. So you should see that we go diagonal through 2 blocks. That's how far away we are. We need to go diagonally through 2 blocks to come up with A prime. So let me kind of undo that. So we went diagonally 2 blocks, and we need to go diagonally 2 blocks again. So that's going to be A prime. The same thing with B. We go diagonal 1 block, so we need to go diagonal another block. So that means B prime is going to be there. And finally, we have C prime. We go 1, 2 and a half. So we go 1 and a half, 2 and a half. That's where it's going to fall. So C prime. So this is my image in blue. And my pre-image is in red. So what happened there? This is the rule. We just changed y and x around. So the new points, A prime, it's just negative 1, positive 3. B prime is negative 2, negative 4. And C prime is going to be 0, 5. So whenever I take a look up here and compare my image with my pre-image, it's easier to see the rule that x and y are just shifted around. That's the rule. So you're asked to find the image given the line of a reflection in the pre-image. You need to find the coordinates. So you have to do problems 1 through 6. You can use those shortcuts that I've had on the last page, or you can make your own graph to help you out. So the directions are actually on this page here. They should be reflected correctly on your papers, though, that you have that were handed out in class. So the last thing we're going to talk about is line symmetry. Line symmetry and reflection are very similar because if I draw a line, it's going to cause a reflection. So basically the way to think of it is if you fold over a sheet of paper, you're going to have two halves match exactly, which is what we have here. So the figure can be folded into two halves and match exactly. So the examples that were given, the first one actually has 4 lines of symmetry. So most of you should be able to see these two without any problems. The other 2 lines of symmetry, there's one right there, and there's one right there. So if you don't believe me, you can actually take a sheet of paper and fold it up and see how it works out. The next one's pretty simple to see. The line of symmetry is going to be right here. So imagine you had that as a sheet of paper and you folded it up. There's no other place that you can fold this that you're going to have 2 equal parts. So the third one, there's no line of symmetry at all. So there's no place where you can fold it that you're going to get the same image on both sides. So doing numbers 1 through 6, again, we have a line of symmetry right there, and that's the only one. For number 2, we're going to have 4 lines of symmetry again. Number 3 is a circle, and a circle has infinitely many lines of symmetry. So anywhere that, so long as it goes through the center, they'll all be lines of symmetry. They could be, you can do that an infinite number of times. Number 4 will actually have no symmetry. You might think that maybe this would work out, but these 2 sides aren't equal to each other. So imagine if you folded it over, for that to work out, these 2 sides would have to be equal, and they're clearly not. So number 4 has no symmetry. Number 5 has 1 line of symmetry right through there. And lastly, number 6 is a triangle. It has a line of symmetry if it's isosceles. So it looks like it's an isosceles triangle, so that would be the line of symmetry. The last thing, we go back to reflections to finish off. I want you to do the reflections over line K. So line K is this line right here. We're going to do the reflections over line L. So line L is this line that goes all the way across. So if I take point X, which is right here, and I flip it over, it's going to go to point H. So the reflection point is point H. Point P is down here. The reflection point is going to be point L. We have segment LM, which is right there. So we can reflect segments, we can reflect shapes. So we have trapezoid. Let me do this one in green. A, B, C, D. So whenever I reflect that, A becomes A prime, or just A, F, E, D. So the order is very important. So that's trapezoid, so I'm going to use that same notation. Trap, A, F, E, D. So again, you do the ones over line K. I hope this was helpful, and please come to class prepared with any questions you might have, and have a great day.